Today's discussion is about velocity. We have seen what is speed in a previous video. We have seen the difference between average speed and instantaneous speed. Today's discussion is revolving around velocity. Okay, let's move on. I'll clear this. So we'll start on a clean slate. Speed. Before going to velocity, let us see speed. Speed tells us how fast an object moves. How fast an object moves. What does velocity tells us? Velocity also tells us how fast, but along with how fast, it also tells us in what direction. So this is the key difference between speed and velocity. How fast and how fast plus direction. So hence we can state that speed is a scalar, and we know that if any quantity has magnitude, that means how fast gives us the magnitude, and direction is also involved, then we call that unit as vector quantity. So let us move ahead to the definitions. Okay, I'll clear this. We'll move ahead to the definitions of velocity. We know that speed is total distance upon total time. This is a scalar. This is a scalar. So velocity is defined as the change in position or displacement. We have studied earlier that if you want to get the displacement, we need to understand what is the initial position and the final position. So that is why velocity is the change in position or the total displacement divided by the total time. This is the formula for velocity. So what is average velocity? Average velocity is the change in displacement upon change in time. That is displacement divided by time. Velocity is This is the formula for velocity. And average velocity is the change in displacement upon the change in time. So let us understand it graphically. I will clear this. If an object, if an object kept here moves from A, and intermediately there's another position here, this position let it be called as x1, and another position here called as x2, and then final position here is called B. Before the object goes from point A to point B, it reaches point x1. It reaches point x1 at time t1, and then after that subsequently it reaches point x2 at time t2. So now how will we define average velocity? Average velocity, we know, is the change in displacement. Change in displacement is measured by the final position. So we take x final as x2 minus the initial position. Now final position and initial position you have to consider with the sign because it is related to displacement. Because displacement tells us the direction as well, divided by t2 minus t1. The denominator is a scalar and the numerator is a vector. So for any vector, we have to consider with the direction. We have to note down the direction by representing x2 and x1 with a sign. So if you change the origin, if I change the origin from A, if I change it on the right side, then all my values here on the left will turn out to be negative. So then x2 will take minus x2 minus minus of x1. That is going to be the change in displacement depending on the where the origin is placed. This is about average velocity. So now let us see what is instantaneous velocity. What is instantaneous velocity? Instantaneous velocity is the change in displacement by change in time when limit delta t tends to 0. This is also written as small change in displacement divided by the small change in time. So now how is average velocity and instantaneous velocity related? Let us see in the next slide. I'll clear this out right now. Average velocity, instantaneous velocity. Average velocity, we write it as AVG. This is the total displacement by total time. And instantaneous velocity, I instant, is equal to small change in displacement by small change in time. So here we know that delta t tends to 0. We have already seen what is instantaneous speed in the previous video. So now when distance, will average velocity and instantaneous velocity be same? When distance, before we find out whether average velocity is going to be same with instantaneous velocity, which obviously is not the case, average velocity and instantaneous velocity will not be the same unless and until delta x is equal to dx. Only then, only then v average will be equal to v instant in terms of magnitude. But in terms of direction, they may not be same because when I'm measuring average velocity, I might consider this as a change in displacement. But when I'm measuring instantaneous velocity, I might consider only this point. So when I consider only this point, my direction will be different as compared to when I'm moving from here to here. That is why the direction, when you consider with respect to direction, it may not be same. Will average velocity be equal to average speed? Let me clear this. V average equal to average speed? It's a question. Not always. What is the definition of average speed? Average speed, average velocity is change in displacement divided by change in time. And speed average is given as s is denoted as speed, so I'll call it as x here as displacement, and this is speed. average speed is given by change in distance divided by change in time. So it is clearly visible here. This is a vector quantity. This is a vector quantity and this is a scalar quantity. That means change in displacement has direction as well. And distance is a scalar quantity. But however, when delta x is equal to delta s, that means displacement is equal to distance, that time average velocity will become equal to average speed. So it is clear from here now, when displacement is not equal to distance, then average velocity is not equal to average speed. So this is clear. We have today talked about velocity. We have seen how velocity, average velocity is different from instantaneous velocity. Then when seen, we have compared average velocity with average speed. So let us summarize it now. I'll clear this. Summary. So we have seen about velocity. Velocity tells us how fast with direction. And we have seen that speed tells us only how fast. Then we have seen the formula for velocity average, which is given by change in displacement divided by, that means the change in position divided by change in time. And instantaneous velocity is given by a very small change in displacement, which is given as dx divided by a very small change in time. This means that delta t tends to 0. We have seen the cases that when displacement is equal to distance, that time average velocity will become equal to average speed. We have also seen that average velocity may not be equal to instantaneous velocity. In most of the times, it is not equal, because average velocity is taken for the full displacement and instantaneous velocity will take for a particular displacement at that particular given time, at that particular time. So the direction may differ. Because the direction may differ. That's why average velocity may not be equal to instantaneous velocity. So we have talked about velocity. So stay tuned on, subscribe, like, and share. We'll be taking up more topics on kinematics as we move ahead. Thank you.